What is Ohm's law? Ohm's law is generally used in electrical circuit. It states that the current through a conductor between 2 points is directly proportional to the voltage across the 2 points, and inversely proportional to the resistance between them. The equation for Ohm's law is V equals to IR, as you can see in the slide, where V is the potential difference or the voltage measured in volts, I is the current measured in amperes, and R is the resistance measured in ohms. All our calculations will be based on this relationship, and we will test our circuit to verify if the relationship is true.
Hello everybody, my name is Rohit Pathak and I'm a student at the University of Utah. Today we'll learn how to use a breadboard, and then we'll go over Ohm's law and see how we can measure different components of the Ohm's law like voltage, current, and resistance. Well, before we go over anything else, let's talk about the breadboard first and what exactly it is and how does it work. This is a common electrical engineering breadboard, and we use this for building circuits. This is a normal size for breadboard. Some breadboards are smaller than this. Few of them are bigger than this, depending upon the complexity of your circuit. Let's go over the physics of the breadboard. It's just a platform we use, or you can say it's a device or just a plate we use to build circuit. As you can see, there are really small holes, a number of holes all over the breadboard. And let's go over the middle section first. There's a line which is basically dividing this breadboard right here, and the middle section is connected vertically. And what I mean vertically is, if you flip it, I just ripped off the back so that we can see how exactly they're connected inside. The middle part is connected vertically, and this is the line which is dividing. That means these two sections are not connected to each other, but they are connected within vertically. If I flip it back, as you see, the top part and the bottom part, they are connected horizontally, as you can see right here. And when we go over how to build the circuit, and then we'll go over Ohm's law, we'll show how these holes, when we connect different wires and different components inside the breadboard, how they are actually connected automatically to each other, and we don't even require a wire. But this is the main physics of the breadboard, and it is widely used because it's really simple and we don't require a number of wires to connect small components. Well, after we have learned about Ohm's law and what voltage, current, and resistance are, we need to talk about the device which actually measures these components. Here we have a multimeter which is used for measuring different electrical engineering components like capacitance, inductance, voltage, current, resistance. And we'll be using the same device for our measurements. This dial usually points on whatever component we need to measure. At this point of time, it is on the ohms. Then we'll be using it to measure the voltage, which is right here, and then the current, which is right here. Well, before we take our measurements, let's go over the Ohm's law once again. Ohm's law is V equals to IR, where V is voltage, I is current, and R is resistance. Since we'll be measuring voltage and current first, and we can measure the resistance straight off the multimeter, let's see how much resistance this resistor has. So what we'll do is we'll connect the two ends like this. And we can get the corresponding value for the resistance. And it is roughly 1 kilo ohm or 970 ohms. This measurement will help us to calculate voltage or current, depending upon what we have and what we're trying to find, and also to build our circuit. Well, now that we have learned about Ohm's law, let's get into some serious building of circuits. This is a breadboard connected with a 9-volt battery. This will be a power source. And the first case we'll be testing is for series resistance. We already measured this resistor as 1.98K, roughly 2 kilo ohms. And it's connected with the 9-volt battery. What we will do is, using this multimeter instead of this multimeter, it's just convenient to use that one, we will measure the current and the voltage. So first thing we will do is to check if we are getting the 9 volts and if we are losing some voltage due to this resistance. So what we will do is just connect the 2 wires. One with this and the other one this. And if you see right here, we get 8.56 volts. The reason behind we do not get 9 volts straight off is basically due to the wires we're using and the resistance, the resistor we're using, which actually obstructs the flow of current, and that's why we lose voltage. Well, after we have measured the voltage and the resistance, it's time to measure current. And by Ohm's law, V equals to IR, and we can measure the current by V over R and find a current. So how are we going to actually do this on the circuit? First of all, we'll switch this from the voltage to current. And then we'll put the multimeter in series with the circuit so that it acts as an emitter and we can measure our current. So what we'll do is unhook the wire, connect it with one end, and the other end will go to the, and we'll see that we get the current as 4.30 milliamps, and if you do the calculations to find current, you'll get something similar to that value. Our second case will be similar to our first case, but except the resistors will be in parallel. We added another resistor in parallel with the 1.9K, and this time we're using 3.8 kilo ohms resistor. And our slides will show how we can add them together and find the equivalent resistance. Let's check and verify if the voltage remains the same in a parallel circuit, and we know that the voltage is similar in the parallel circuit and everywhere. So what we'll do is check the voltage, just like we did in the last case. And as we can see, we get 8.557, which is very, very close to what we got in the first case. In the first case, we got 8.65 volts, and now we get 8.55, which is roughly close to what we had last time. So now that we have verified our voltage, we can go on to the current. The final part of our measurements will be verifying what current we get from this parallel circuit. So what we'll do is put this multimeter in series with the circuit. Don't forget to switch it from voltage to current. And we get 6.50 milliamps, which is very, very close to what we measured through calculations, and which verifies that Ohm's law works perfectly for this circuit. Now that we have learned how to use Ohm's law and how to build a circuit on a breadboard, we have actually mastered the Ohm's law. We know how to use and measure voltage, current, and resistance, and we can also measure resistance through a multimeter. Well, since Ohm's law is such an important law and it is widely used in electrical engineering, I would really recommend to do as many calculations as possible to actually have a good practice at it. Well, hopefully you have a good time, and I'll wish you good luck for your future experiments and classes.